Now let's start dienone phenol rearrangement. Dienone phenol. Now the name suggests di-in one. Di means two, in means double bond, and one means ketone. It will be converted to phenol type of compound. Now, for example, I have one molecule. This is di-in, one di-in, and this is one di-in one. For example, this center, this will be sp3 center. Suppose there are two methyl groups. If we treat it with H plus, what will happen? First, we know oxygen will be protonated because it is electrophile. This oxygen is nucleophile. What happens? This OH will take proton, then this bond will move to oxygen. So OH and plus, right? So carbocation is getting formed. Now this can undergo resonance. So the resonating structure will be OH and this. Now this is one carbocation where a beautiful migration will occur among these two group. For example, this group will migrate. Then what will happen? There will be positive charge. At this center, there was one hydrogen, and this will basically aromatize the system. So finally, we are getting phenol type of compound. So one para and one meta group we will have. Okay, very much simple.
Yeah.
So the rule is, if there are two different group, G1 and G2, G2 will migrate if the resultant cation is very much stable. Okay, so it depends on G1. Okay, so which can stabilize more. Now if two groups are given like this, double bond O, for example, one is phenyl, another one is CO2 ET, then obviously, if phenyl migrates, then the positive charge will be with CO2 ET, and CO2 ET is electron withdrawing group, and that will be very much unstable. So CO2 ET if migrate, then it will be more favorable, right? Have you understood?
Yes.
So the product is simply CO2 ET and phenyl. Okay, now if there is one, if there is any group with one heteroatom, okay, or any ring, suppose, etc., any ring or heteroatom, any ring with one heteroatom, then this heteroatom with its lone pair, when positive charge will come at this center, then the heteroatom will have a tendency to donate its lone pair very fast here, so then that group will migrate. For example, if question is, double bond O, double bond O, so oxygen will migrate, one ring and heteroatom, so oxygen will migrate here, so our resultant product will be OH, oxygen, CH2, 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 1 2 3 carbon and one oxygen, 1 2 3 carbon and one oxygen. This will be the product, right?
Yeah.
Now tell me, if simply this is given NHO No. First is selenium. Second is H plus. Selenium, what will do? This is a reagent which does the actually uh, it will make here double bond. It will remove two hydrogen that will basically oxidize the system. So we will be getting the selenium reagent. We will be getting our Dienone phenol rearrangement product. Sorry, reagent or starting material NH. Now, which group will migrate? Oxygen or nitrogen?
Nitrogen.
Nitrogen. So our product will be OH, aromaticity, oxygen, NH, like this. Okay. So if there is a comparison with oxygen and sulfur, then sulfur will be migrated. Then it will be nitrogen most. Okay. Then S, then O. This will be the migratory nature if lone pair is there. Okay. Now another question. Okay. H2SO4. It means H plus. What will happen?
Double bond formation. I mean,
Dub
double bond. Oh, sorry, carbonyl group.
carbonyl. This is basically protection deprotection.
Yeah.
Right. So this will be simply hydroquinone. Right.
Hmm.
Now if the question is this with H2SO4, then what will happen? First, it will make the dinonphenol rearrangement starting material, isn't it?
Yeah.
Then with the rearrangement, first it will make double bond O, this, and after that, after the rearrangement, we will be getting phenol and this, right?
Yeah.
Okay. In one very standard book, I have found one example. Double bond O, CH3 and OH. What they have done, they have written the final product as CH3OH, and they are saying that basically OH will stabilize the carbocation. Okay, and that's why OH will remain there and methyl will migrate. Okay,
Hmm.
so whenever there is a ring, uh, just do the migration with that order NSO, and if there is no ring, then do like this. Okay, consider the carbocation stability. This is from
Okay.
Claydon. The Claydon is considered as Bible of organic chemistry. So here they have given this particular example. Okay. Okay. Another example, the final example, double bond O, CH3 versus phenyl. Again, in this example, phenyl will migrate because the pi cloud is actually, it shows that this donating ability of the lone pair or group, etc. This has some effect. So phenyl ring will migrate. Here it is found that there will be OH and CH3 and phenyl. These are all the example, and some confusing examples also have added with some sources. This is all about our Dienone phenol rearrangement. Okay. Any doubt?
No.
Okay. Okay, so let's end this session.